So, like I said, my name's Tyler Walker. Arvind and I are doing kind of like a good cop, bad cop thing, and he was the good cop. So, yeah, no, we'll get into it. So I just wanted to highlight SAP Concur again. So we are hiring. Our new stack is mostly Node, React, Redux, and GraphQL. So if you have experience in any of those things and you want to learn more about the company, we do have 2 people on the recruiting staff here. They'll be posted outside. So if you are interested, feel free to contact them. My contact information will also be on the React meetup. You'll get my slides. Twitter is a really great way to get a hold of me as well. I have my handle on there. So a little bit more about myself. So I graduated from Washington State University in December of 2017. I studied computer science, and then I joined Concur in March of 2018. So this is my dog, Rainier. She's a German Shepherd Husky and takes up about 85% of my time. And one of the reasons why I wanted to put her on here is SAP Concur is really good at letting you work from home. When I got her, so she was 8 weeks. When I first took her home, she was a tiny baby. I thought about putting one of those pictures up, but that's cheating. So that was just taken this past Sunday. We went up to Snoqualmie. But so SAP Concur has enabled me to raise this little puppy because I didn't have to keep her in a crate all the time. I work from home almost most of the time. So as she was growing up, my first year of having her, I was able to, work from home and like really control my own time. She requires a lot of energy, but the whole anecdote there is SAP Concur is a great place to work. I really like all the people I work with. So sales pitch over there. The other thing is the rainbows. So I sent my presentation slides to one of my friends down in the South. And one of the first things they said is like, you know that I only had that one picture on the right. They said, you know that there's a rainbow in that picture, right? I was like, fully aware. And they're like, and that's a work presentation? Fully aware. And ever since we had that conversation and he explained to me, what the culture is like down there, I just wanted to appreciate the fact that, I am giving this presentation at work. All of my managers are here, so, another reason why this area is a great place to work. Again, sales pitch over. Oh, and the guy on the right, any Star Trek fans? Yeah. Maybe?
I hope everyone knows who that is.
That's George Takei, America's gay uncle.
George Takei fan. Not from a Star Trek, but George Takei fan.
Yeah, there you go. You can be a fan of him without it. No, I didn't watch Star Trek.
Is that his husband in the picture?
Yeah, that's Brad. Cool. Okay, again, more build up to this whole decoupled application development. So, Penn and Teller, does people know? Yeah. Mm-hmm. So this is Teller. He dropped his first name a long time ago, so I don't have to know what it is. But there was somebody on Twitter who had posted about this, and I thought that was like kind of like a genius thing for both development and just like leadership, is make the secret a lot more than the trick seems worth. Because they were just asking, how do you get away with your tricks? How do you do that? And I always thought that was a little bit interesting. One of the themes of this talk is going to be doing a little bit more investment up front for benefits down the road. Yeah. How many of you have lost power in the past year? Oh, good. This will resonate with you. So this is an example of a power outage. Your house is tightly coupled to the electric grid. Barring the fact that a lot of these alarm clocks have battery backups, we'll pretend like that's not the world that we live in. Your radio, your alarm clock is tightly coupled to the power source that is plugged into, which is plugged into a power grid. When your power goes out, so does your alarm clock. You can't really tell on here, but that person has 3 alarms set. I have 5. 601, 602, 603. That is about what it takes to get me out of bed before 11. And so as I was building this talk, when I first started on my team, I had come into a really nice code base, something that the people on it really enjoyed developing in it, and it's kind of unique throughout Concur. And So I got the benefits, but I didn't really understand it. So now that I've been here for a little bit longer, I've been here for about 10 months, this is me looking back on what I've learned. So your alarm clock tightly coupled. When your power goes out, your alarm clock goes out, you will not be woken up, right? That's not the world we live in anymore. Most people have their alarms on their phones. If it's not most people, it's just me, and that's most people. If your alarm is on your phone, then and your phone has that battery backup, as long as it's charged, I have not worried about a power outage not waking me up in the morning. There's been plenty of times where the power goes out and my alarm wakes me up the next morning, and I'm just fine. That is the idea that we're going to start talking about, is the idea of tightly coupled, loosely coupled, and decoupled. So getting into the tech side of it, upstream dependencies. So if you are building an application that consumes data, which is most of them, services must be running for the application to work. So if you work for a big company, you either have like a monolith or microservices that your application consumes. If those services are not up, your application will probably not work. Hiccups and APIs are showstoppers for UI engineers. If you are trying to build your application and the API keeps giving you errors, you can't log into it, for whatever reason, if it's not working, that takes any productivity that you have as a UI engineer completely away. I have experienced that firsthand, and it is not super fun. I also have like really bad ADHD, so like if I'm not like in that train of like developing, like if it keeps getting slowed down, like any slowdowns for me are amplified just because I'm really bad at switching tasks. And then another thing is that APIs aren't guaranteed to work when they are supposed to, or aren't guaranteed to be delivered when it's time to do the UI work. So as a UI engineer, if you are waiting for a new API to be developed, if that gets delayed and you are in a spot where your team is reliant on a new API to come online before you start the work, you just won't be able to start that work yet, which is frustrating. Gifts for relevance and comedic relief. But it's like I said, so for me it's really bad when things starts getting slow for me, my mind starts to wander. I am really bad at like really staying focused. So that's something that, when things go up and down or it's just down, it's difficult to work. It's frustrating. The last presentation I did was about performance, and one of the anecdotes that I had was that like every second or something that a user spends waiting for a page to load increases frustration. And I think that is something that developers and management probably don't take, when talking about whether or not you like an app or not, the timeliness of something loading and how quick it loads really is, the general feel that you take away from it. Frustration is hard to measure, but it's easy to feel. Yeah, frustration during development, major time waster. It's, you don't want developers sitting at a point where they're sitting and being like, I don't have anything to do. So introduce decoupled development. So this is the high level concept is that you are going to be able to divorce your API and your reliance on APIs and your application. Or as the kids might say, 100 heart eyes. Does anybody know where that unicorn's from? I just recently was introduced to it.
It looks so familiar.
GitHub was just down. And GitHub's 500, sorry, we can't, the server error page, that was their little server error. I thought it was cute, and I was like, right click, save as. So yeah, we're getting really excited about decoupled development. Another main concept that I want to drive home is developing on contracts. So it's not Bitcoin. We are not talking about smart contracts on the blockchains. We're just saying basically handshakes. So the idea is that so this is the typical, I would say, probably abstract hierarchy of most applications. If you're using React and that pink one is GraphQL, you have a React application that makes calls to the GraphQL server or that makes calls to an API server. that makes queries to the database. That is, I would say, pretty typical. So something that my team has been doing is when we know what the response from an API, one of our services looks like, we can start building our GraphQL resolvers, and we can start building the UI. We do not have to wait for all of the pieces to be done and in place. We can start building ahead of time, and then just put the things together. And there have been multiple times where we do build a full feature before the APIs are complete, and tie it together and try it, and it just works. I think we've said that. There's a few times where we've said it like, it just works, and that is not something that I hear a lot. So, driving the point home, once you know the shape of your data, you can start building your UI. So I just went online and I looked up Instagram's, I just looked up JSON responses. And the idea is that if this is an example of what comes out of your API, you can mock this. If they tell you what the shape of it's going to look like, you're going to have a longitude, latitude, ID, and name. You can make that up. You can write that into a JSON file, and then you can start building a UI that references that JSON file. It's almost like you could do it blind.
I sense a theme.
Say that again?
Oh, I said I sense a theme.
Yeah, I know, right? I was the first one to have it, and then they figured out earlier today how to incorporate it into theirs.
Trendsetter.
I'm a thought leader like that. So, yeah. So, I mean, that's the big thing. Is you can start building your UI when things are down. You can build your UI when you don't know what the API is going to look like. You can start prototyping things before you know what they look like. Or, you know, if you just have an idea like, oh, well, what if we did it like this? You can do that. We've done that with our GraphQL resolvers and our React stuff. My team specifically is like half stack, or like, yeah, I'd say half stack. So we have it's UI engineering. So we do the UI and we maintain our GraphQL resolvers. So we are not full stack in the sense that we own the API in the database, but we basically, the contract is that somebody will give us the API endpoints and then we take it from there. And so we've had several times successfully where we look at a design and we look at what responses we're supposed to get. We can shape our state for Redux, and we can start looking at what GraphQL might look like. And we can start building things regardless of whether or not the services are up or if they're even ready to begin with. So that brings us into factoring the applications. So this is more of our approach and how we build these decoupled applications. So 4 main things: your app hosts, your apps, data clients, and servers. App hosts are where the contracts happen. I will talk about in the next slide. Your apps is your presentation layer only. Basically what you can make with Create React App, it has your state, so your React, Redux, your containers, pages, all of those things. Anything that you're doing with React and Redux live in the apps. Your data clients are, so you have 2, integrated and test. I will talk again more about those, but the idea is that in the integrated, you're actually making API calls. In the test, you're only doing, you're looking at mock data, test data. And both of those packages just return promises. So you bring in the data client, and you bring in the promise. If you're not familiar with JavaScript, promises is fancy for asynchronous. And the servers are what actually runs the app. So the integrated will run everything. The test will only run what you need. So promised that I was going to get into the app hosts, so here we are. So again, integrated. You're going to actually make calls to the endpoints. You're going to send logs to actual log servers. Likely going to require authentication unless your application just doesn't do authentication. And then provide full localization. So so the contract abilities that I'm talking about are loggers. You can do a logger.log, and you can abstract that away where if whatever framework you're using in your integrated way, or I believe that for us, when we do our test logging, we just send it to the console. We don't do anything fancy with it. And so most of the time, getting back to that power outage analogy, we are able to work regardless of whether or not the power is on. There's been multiple times where services are just down, and some teams have to continue building without seeing, without actually testing their code. Whereas we just build the UI and then tie it together at the end. I think that's all I wanted to say about that. So the development modes. So like I've been hinting at, we kind of run in two modes. So it's a little bit duplicated, but those two modes provide entirely different capabilities. So it is as easy as, like, the way that we run it is, it's a difference between how you say npm run. So in this, I just said npm run app coupled, and then the other one is npm run app decoupled. So coupled lives inside a real server. You bring in all of your real-time dependencies. This is basically what's going to be sent to production. This is closer to what you will be deploying than the other one. Integrates the application into the actual development environment, so you're calling real APIs, you're using actual authentication, and you're getting real session tokens. So this is very real world, power's on, you are 100% relying on the power. When other things are not working, so if your power is off, this will not work. You need everything to be in perfect harmony for this to work. And luckily, for most times when you're in production, a lot of those things are up more. But development environments, when you're working with other teams that are developing, it's not, like, sometimes they're like, well, we broke a thing and we're trying to fix it. In production, it's a lot happier. npm run app decoupled. So it just runs inside the create React app. You have local files for all of your responses. No config webpack, and then I will talk about demo page for scenarios. This is another thing that some of my colleagues brought up, and it was like, it just put me in a new frame of thinking, is whenever we look at our designs, designs are obviously not always comprehensive, but we have one question that is always asked, which is, what does it look like when it's loading? What does it look like when it fails? And so that's kind of the way that we've started developing is you create this demo page and you can trick the UI into these different states that you want it to be in. And it's fast. The amount of time that we've spent on small features is just, it's not the same as when you have to work on an application that is tightly coupled to its dependencies. You write the fake data. Those responses are really fast. You can imagine that when you're making a request to a test data source or like a development data source, and you're using actual network traffic, you are reliant on those services. When you're doing this, I think we say, wait 5 milliseconds or whatever, and then send the data. It's almost instant. Yeah. So again, the main thing that we do is we run 2 different types of apps. You're only writing the UI part in one place. You're writing it once, and then you have these 2 different environments that you can run it in. And I cannot emphasize how much I enjoyed working on a decoupled app. Being able to mock those things and knowing, what does it look like when this request comes in. It puts you in a very different frame of thinking, and I think it takes advantage of the best parts of React and Redux. So creating a data client. So the data client is where your data is coming from, if that's not obvious. So what happens from a higher level is you have these promises. So if we're going to go back to that Instagram thing where you're talking about locations, your integrated data client will have a function called get all locations. And it's going to make a request to some server bring it back, and then that promise will give you that data. When you go to the test data client, it will make a call to the local file on your machine and bring it in. But you have the same functions all the way down because that is how you simulate the two. So the first thing is refactor your API consumption away from the Redux action creator. So if you have functions that make API calls in your action creators, you can't mock it at that point. The Redux action creator should be pulling from the data client. Develop a data client module that returns the query and mutation functions. So you have like I said, the integrated in test data clients, and you have them have the same functionality all the way down. And that's going to be, so queries is getting data, mutations is changing data, so sending post requests and things like that. The Redux action creators provide the API context. Again, so we talked a little bit more about the contract. So if you can solidify the contract between the data client and the app, and you say, this is what it's going to look like within the live environment, and this is what it looks like in the test environment, as long as they operate the same way. It's basically, if you've taken any like software engineering classes, if you're familiar with interfaces, they look the same, they operate the same, but they don't behave the same. So what they actually do down below is different. But because they act and look the same, the application doesn't know any different. So you just plug in one of the packages, and then you move the data client into its own package. So in ours, we have, at the root level, we have a data client package. So you either have data client integrated or data client test, and that is what does the magic of mocking your data. I imagine this is like, bright lights. You're like, that was a lot. But I did want to go into that for the more technical folks, who, if you're interested in building this on your own, those are the steps that you're going to need to go through to get your application in a state that is going to be more decoupled. So I've seen this view equals a function of state in like almost every single React presentation I've seen. It's very common. I've like avoided using it in other ones because it's so overused, but this is really, really relevant to what we're talking about right now. And so one of the things that I mentioned earlier was demo pages. So I'm going to be going over one of the applications that my team built and showing how we use these demo pages. But basically, it's one page where you can simulate all of the application. So you control the state of the application, and if you can control the state, you can control the view. And I will go into how that works. So this is, we call it list builder. It builds lists. You can view them, you can see them, you can change them. So you can imagine that if you got a bug and they said, well, when I have 100 items in a list, the app starts going crazy. Well, if you are a developer and you need to produce that, you don't want to have to press add 100 times. That's really difficult. So we have these things called demo pages that allow us to simulate the page the application in different ways. All of these links literally just pull up some fake state and trick the application. So that's where that view equals function of state. So we take this pre-baked state out of the oven ahead of time, and then we can go back and the application will have changed. And really the only thing that changes is the state. Is we load the state and manipulate the state in a way that you don't have to do everything by hand. And that's one of the nicest things about having these decoupled applications is that if you start to treat your UI layer as UI only and you don't make it do things it shouldn't do, which is make the data calls to the APIs itself, and you can actually tear these things apart and keep the UI layer only doing UI things, when you start manipulating the state, it's a lot easier to see your application in its various states. So bringing it home, the benefits that I've seen, like I said earlier, I truly enjoyed working on that. It was a great thing to learn. This is my first big boy job out of college, and working on that project was very unique. It brought home a lot of the software engineering principles that I'd learned before, and it was just really exciting to work on. Other than that, engineers are able to work faster and write cleaner code. You stay strict about these contracts, and if you stay principled, you will just it's all benefits. You can quickly prototype new ideas without service dependencies, and then it's less frustrating. Fewer FPMs. Does anybody know what an FPM is?
I can guess.
It's your fucks per minute. Yeah, it is. I've been working on an application that is not in that decoupled state, and it's a lot more frustrating. There's a lot more waiting. It's a lot more, is this thing up, is this thing down? When you are in that decoupled state, it's nice because you know that whatever issues you're seeing, you could run it live and you can run it local, and you can see, are there issues in the live server that aren't in the test environment? It makes debugging a lot easier. Yeah, got the fucks per minute one. That's the joke for that slide. Sweet. All right. Last thing. This is my last slide. To write clean code, you must first write dirty code and then clean it. One of my things, and I said this about the performance as well, is it is really difficult to anticipate problems before you have them, unless you have a lot of the experience. And so if you are writing your own personal projects, you may not need to jump into this environment. There's a lot of value in building it straightforward one way and then getting it used to refactoring. Refactoring code is one of the things that is a lot more difficult for me because you have so many pieces of code in flight. That's something that I'm trying to get better at. But it is okay to write dirty code. It is okay to prototype it and get it at the door, kind of like what Arvind was saying. But eventually you can clean it. Yeah, I think that's it.